Good day everyone, this is XK Tutor. So today we're going to try and answer a problem on thermal expansion. So here is the problem. An aluminum alloy rod has a length of 10 centimeters at 20 degrees Celsius and a length of 10.015 centimeters at the boiling point of water. What is the length of the rod at the freezing point of water? Then, what is the temperature if the length of the rod is 10.009 centimeters? So what are we going to do here? First, let's list down all the given. So given are the length of the rod at 20 degrees Celsius. I just change it to color white. The length of the rod at 20 degrees Celsius is 10 centimeters. Then the length of the rod at the boiling point of water. So the boiling point of water is 100 degrees Celsius is 10.015 centimeters. So here we can now calculate the change in L. That would be equal to 10.015 centimeters minus 10 centimeters, and change in L is equal to 0.015 centimeters. Change in T, 100 degrees Celsius minus 20 degrees Celsius, that would be equal to 80 degrees Celsius. So what are we finding here? In the first part, we're finding what is the length of the rod at the freezing point of water. So L at 0 degrees Celsius, and B is temperature if the length of the rod is 10.009 centimeters. T at length equals 10.009 centimeters. So we're going to solve the problem. Let's go to part A. L at 0 degrees Celsius. So the formula we're going to use is change in L is equal to L alpha change in T. We can notice here that we don't have the value for the alpha. So we're going to compute first, we're going to get the value first of the alpha. So by manipulating the formula, we're going to divide both sides by L and change in T. So let's cancel this here. So we have a formula now for alpha. Alpha is equal to change in L over L times change in T. So by plugging the given, change in L is equal to 0.015 centimeters. Our L is 10 centimeters and change in T is 80 degrees Celsius. So we're going to cancel this centimeter and centimeter, and this is approximately 1.875 times 10 raised to negative 5 per degrees Celsius. So we now have the value for alpha. So let's now compute for L. So next we're going to compute for the change in temperature, since temperature for part A, okay? The final temperature is the freezing point. So it is 0 degrees Celsius. Then subtract the initial temperature, which is 20 degrees Celsius, and that would be equal to negative 20 degrees Celsius. Then we're going to compute for the change in L. Change in L is equal to L alpha change in T. Then we're going to plug the given. L is 10 centimeters. Alpha is 1.875 times 10 raised to negative 5 per degree Celsius times the change in T, which is negative 20 degrees Celsius. Then if we use calculator here, you'll get negative 3.75 times 10 raised to negative 3 centimeters, or we can rewrite it as negative 0.00375 centimeters. The answer we get here is not yet the final answer, because we're looking for the length of the rod at the freezing point of the water. This here is only the how much it expands when it is at the freezing point of the water. Negative means it decreases. So to get the final answer, we need to add the original length plus the one we get here. So L now is equal, final length is equal to 10 centimeters plus negative 0.00375 centimeters. And our final answer would be 9.99625 centimeters. We're going to solve for temperature at L is equal to 10.009 centimeters. The formula is change in L is equal to L alpha change in T. Since we're looking for the temperature, we're going to divide both sides by L and alpha, and this will cancel out. So we now have a formula for change in T, which is equal to change in L over L alpha. By substituting the given, change in L is equal to change in L here is 10.009 minus the original length, which is 10 centimeters, and change in L now would be equal to 0.009 centimeters. So that would be the new value for the change in L. Change in L is 0.009 centimeters over by the original length, which is 10 centimeters, multiplied by the alpha, 1.875 times 10 raised to negative 5 per degrees Celsius. Then let's cancel out centimeter and centimeter. Then using our calculator, we can get change in T is equal to 48 degrees Celsius. That is not yet the final answer, since we're looking for the temperature. Here is the change in temperature. The formula for change in temperature is equal to the final temperature minus the initial temperature. So we now have a value for change in temperature, which is 48 degrees Celsius, is equal to what we're looking here is the final temperature, so that is unknown, minus the initial temperature is 20 degrees Celsius. Then we can now solve for the final temperature, which is 48 degrees Celsius minus 20 degrees Celsius, and our final answer would be equal to 68 degrees Celsius. So that's it, guys. I hope you learned something today.